Hello students, here is Mr. Sims presents recorded lesson videos, and actually this might be the last lesson video of the school year, depending on what we decide to do after our final exam. So at this point you've worked on the checkpoint for the surface area problems, and now we're moving on to volume, which we did in Fast and Furious in the previous class. So this should be a just a general review, and then there's a checkpoint, and then exercises afterwards. So volume we defined in Fast and Furious as is basically the inside of a three-dimensional object. Think of if you want to fill something up with like water. There's a general formula for volume of specific figures, and we reviewed it, where volume is equal to capital B times H, where the capital B represents the base area. And the base area basically depends on the shape of the base. If it's a square, you find the area of a square. If it's a rectangle, area of a rectangle. If it's a circle, area of a circle. So this generic formula can be used for a lot of different shapes, depending on what the shape of the base is. If it's triangular base, you find the area of the triangle. All right, H represents clearly the height. The two shapes that we're going to look specifically at, which we did in Fast and Furious, is going to be the rectangular prism. So if we think about the formula being capital B times H, well, the base area of a rectangle is length times width. So we really could just use the formula length times width times height. Right? So that's where that kind of formula comes from. Right? So if the substitute, so really they call this substitution in math, where you take out something of equal value. All right, so here's example number 3, and we're going to find the volume of each prism. So the bases, shape of a rectangle with dimensions of 8 and 4, and the height is 15. All right, well, if that's the case, then you take volume equals length times width times height. So we take 8 times 4 times 15. Okay, so then it's just multiplying. What do I do with that calculator? 8 times 4 times 15. Oops, clear. And we get 480, and no units. So we'll just say cube units. Right. So in example 2, now I've got a picture. Right. We got a 4 feet by 3.5 feet by 2 feet. Volume equals length times width times height. So we just take 4 times 3.5 times 2. And what's nice about this formula is that multiplication is commutative, which means that we can rearrange these numbers and multiply in any order. So even if you get these numbers in the wrong spots, you're still going to end up with the correct answer. So that's one thing that's very fortunate about this formula, and it's very, very easy to work with. All right, so we get 28. 28 feet cubed. Remember, it's three-dimensional. Focus a little bit. All right, moving on to the cylinder. The cylinder is the one that's going to be a little bit more complicated. It's a different type of formula, but it really does follow the premise of base area times height. So here's a cylinder. So typically in a cylinder you have a radius or a diameter. All right, and then your height would be along the curved side, where the label would go. Let's say if it's a soup can. Right, so if you think about the formula of area equals base area times height, the area of the base, the area of a circle is pi r squared. So really we can just use the formula pi r squared h, which is what we did in Fast and Furious in the last class. Right. So using this formula, now going down here. So example 4, find the radius of a base and the height of a right circular cylinder are given. Find the volume. So volume equals, and we're going to not worry, we're just going to go to the nearest tenth. We're not going to worry about in terms of pi. All right, so we got volume equals pi r squared h. Radius is 11, height is 20, so we get pi times 11 squared times 20. And typically what I like to do, and this is a good habit to get into, especially for later on when you do problems like this, is we're going to do the 11 squared times 20 first. And we get 2420, 2420. And I'm going to tack the pi on there. All right, it's a good habit to get into to do this, because later on in math they may ask you to leave it in terms of pi. All right, so now I can take this 2420 and multiply it times the pi button, and I get 7 0.602 to the nearest tenth would be 0.7, and we would say centimeters cubed. Right. Okay. So now the only thing that is really going to trip a lot of you up, actually I'll move this down and I'll do this. Is this one here, which in theory doesn't look too bad, but here's what we run into. So volume equals pi r squared h. So we got the radius, we got the height, but notice here, meters, centimeters. Okay, on the reference sheet that's provided for you, they'll have some basic conversions on there about how to convert centimeters to meters. So when you have a scenario where the units don't match, you have to have the same units before you can use this formula. All right, so your options are to convert meters to centimeters or to convert centimeters to meters. All right, so right now we know that 1 meter equals 100 centimeters. Okay. So probably what I would think to do is, I don't like decimals, so 2 meters would equal 200 centimeters. So that's what I'm going to do. I'm going to convert to centimeters. So I'm going to have volume equals pi times 200 squared times 65. Okay. The other thing you could do too is if you converted the centimeters to meters, that 0.6, it would be 0.65 meters. You'd have to move it 2 decimal points, but let's just stick with the centimeters here. So 200, it's going to be a big number, but we get those from time to time. 200 squared times 65, and we get 26, 1, 2, 3, 4, 5 times pi. So this is going to be a big number. You can see that's where I ended up there. So now I'm going to take times pi, and I get a pretty big number. I get 8,168,140.9. So oops, move this up so you can see. All right, so from here, next would be checkpoint number 2, which is just finding the volume of 2 cylinders here. And then once you're checkpoint number 2, then you move to the independent practice, which is a mix of volume and surface area. So, all right, for recorded lessons, this is Mr. Sims signing off.